What we're going to be talking about today is amines and amides. Now, these are nitrogen compounds, and amines are sort of like alcohols, and amides are sort of like esters. They act very similar. In other words, they combine up with acids. And a lot of the chemistry from Unit 3 can be used in this unit as well. Okay, now the thing about amines, it involves nitrogen compounds. Now, nitrogen is in some ways sort of like oxygen. It's got an unbonded electron pair, just like oxygen has two of them. Now, the thing about unbonded electron pairs, it is an incorrect term to call it an unbonded electron pair. There's a special bond that can form. I'm going to talk about in a minute here. But anyway, so in some ways, the nitrogen compounds have a lot of intermolecular forces because they form hydrogen bonds. But they aren't as strong as the hydrogen bonds in oxygen. And that's because the electronegativity of oxygen is greater than the electronegativity of nitrogen. And the most electronegative of all the elements is fluorine. I don't talk about that much in this class because it's not in our body at all, except when we introduce it in our water system, which is going to be taken away next year. Okay. Okay. So what can happen with an electron pair and an atom that has no electrons whatsoever? For example, hydrogen cation has no electrons at all. It only has one when it's neutral, and then when it's gone, forms a +1 ion. It has no electrons at all. However, its full shell for stability needs 2 electrons. So what happens is let's see, let's do this in a different color. It forms a coordinate covalent bond with the electron pair on the nitrogen. Now, this can also happen with oxygen. And I don't know if in your 305 class whether they've talked about it, but basically, when you have a hydrogen ion coming from an acid, for example, it can form a bond with one of the electron pairs off of oxygen, and it forms something called a hydronium ion. Which is so in water, that is the correct way to write H plus. Frequently in lower level chemistry classes, they'll just say an acid will dissociate to H plus, but really it dissociates to a hydronium ion if it's in a water situation. Okay, so ammonia does the same thing, NH3 when it's in water. Excuse me, when it's around an H plus ion. And it forms an ion called ammonium ion. And this is what makes nitrogen compounds act like bases. It's because they can accept a proton or a hydrogen ion. Okay. So this concept of non-bonding electron pair is a misnomer. By the way, I've been having an insect invitation in my house, and I invented a new way to get rid of them. It involves ammonia. What I do is I mix ammonia and water together to form ammonium hydroxide. And the bugs do not like that. 2 squirts and they fall over. Uh, and what's nice about this is a gas. And what they do is they bubble ammonia through water to make this ammonium hydroxide. Now, whenever you clean with ammonia, you're not cleaning with ammonia, you're cleaning with ammonium hydroxide. Now, what's nice about using that is that when this dries up, the gas goes away and you're left with plain old water. So it leaves no residue, nothing. It's very nice to use. And if you buy Parsons ammonia, it's also very cheap. So you can make a spray bottle of this with about a, well, I don't know, 10 to 15 dilution rate for about 50 cents. And it lasts a long time. Okay, anyway. So like alcohols, amines can be primary, secondary, tertiary. And like primary alcohols have 2 hydrogens. Secondary alcohols have 1 alcohol, 1 hydrogen. Tertiary alcohols have none. Same with amines. Primary amines have 2, secondary amines have 1, tertiary amines have none. Now, we can go one more level and go quaternary. And that's the ammonium ion I spoke of a minute ago, which is right there. Okay, and we can frequently amines are used as a in common naming format. And what you do is you name the amine and then its group hanging off of it. And don't forget, nitrogen has 3 bonds, like when we do Lewis diagrams for nitrogen. So if it's methylamine, that means one of them is a methyl group. And the other 2 are hydrogens. Dimethylamine has 2 branches off the nitrogen with 1 hydrogen. And this one would be methyl ethyl amine. One thing on OneNote I don't like, it sometimes doesn't allow you to do squiggly lines. And of course, we would alphabetize this. Ethyl comes before methyl. And that's the common name, not the IUPAC name. IUPAC name is different with amines. Now, when we're using the IUPAC name for amines, the NH2 group, the amino group, is treated as a branch, not the main functional group. So like this is treated as a propane with a branch at carbon number 2. So it's 2-amino propane. 1, 2, 3, 4. So that's a 4-carbon alcohol with a branch at carbon number 2 and carbon number 4. Okay, so it's amines are different than everything else. Normally, we have a unit, that's the functional group, whatever is in that unit. Does that make sense? Okay, now with nitrogens, like if we have a carbon branch, when we have a nitrogen branch, we can have carbon groups coming off of this nitrogen. Okay, in this case, there are only hydrogens attached to that nitrogen. So we would name this as 1, 2, 3, 4, 5, 5-carbon backbone. And it's an amine. Now, the IUPAC way to name this would be 2-amino pentane. Okay, 5-carbon backbone, alkane in this case. And there's a branch at carbon number 2, 2-amino pentane. Or if we name this the common way, it would be 2-pentaamine. That makes sense? Okay, let's look at this guy here. We've got 1, 2, 3, 4. So it's a 4-carbon alkane backbone with a branch at carbon number 1 and 3. So 1-amino 3-methyl butane. Now notice this one. Okay, first of all, it's a 1, 2, 3, 4, 4-carbon alkane backbone. That means it's a butane. We have a branch at carbon number 2. And we have a methyl group on the nitrogen branch. Okay, that's distinguished by this uppercase italicized N. So, and it's a methyl. So we're going to go N-methyl 2-amino butane. Okay, let's look at this guy here. Okay, well, this is an alcohol. 1, 2, 3, 4. So it's a butanol. We have a branch at 1, 2, 3. An amino branch, so that's 3 amino. And we have a methyl group coming off that amino group. So it's going to be N-methyl 3-amino butanol. Let's do a few more examples here. Okay, so this is an alcohol. 1, 2, 3, 4, 5. So it's a pentanol. And we have an amino branch at position 1, 2, 3, 4. And we have an ethyl and a methyl group coming off of that nitrogen. So it's going to be big N, ethyl, methyl, 4-amino pentanol. Okay, so let's name this guy. Okay, so we have 1, 2, 3, 4, 5, 6, 7. And it's an alcohol. It means it's a heptanol. And the functional group is on carbon number 2. And we have an amine branch at 2, 3, 4, 5, 6. So it's going to be 6 amino. And we have non-hydrogens coming off of the nitrogen, 2 ethyl groups. So it's going to be diethyl 6 amino 2 heptanol. So it flows in with all of our naming, except for some big exceptions. Okay. One, as far as IUPAC goes, the amine is a branch, not a functional group in terms of naming. Number 2, you have to name any groups off of the amine with a uppercase italicized N. Okay, So any questions about that naming? So this would be the common IUPAC. Common IUPAC. Now, I may ask you on a test, name it two different ways. Okay. Okay, like with an aromatic acid like benzoic acid or phenol, um, the aromatic um, version of all that is called aniline. Aniline. So to name, and that would be carbon number one also, like all the others. Okay, so we're going to use the aniline as the base. If we have anything coming off of the nitrogen, that's going to be denoted by the uppercase N again, and any other branches. Now E comes before M, so the ethyl would come before the methyl here. Okay, as far as IMFs go, because we have a nitrogen oxygen bonding with hydrogen, we can form hydrogen bonds. Primary ones, secondary ones, but not tertiary ones very easily. Okay, and because the nitrogen is further away from the fluorine, its electronegativity properties are weaker. Hence, the hydrogen bonds aren't as strong as with oxygen. Okay, like if we were to look at water, this is going to be partially positive, partially negative. With nitrogen compounds, we have something similar. That nitrogen is partially negative. The hydrogen is going to be partially positive. So things that are soluble in water are also soluble in ammonia for the same reason. Strong intermolecular forces. Boiling point for water is high. Boiling point for ammonia is also high. Now, if we look at intermolecular force trends, these are primary, and as the molecular mass increases, the boiling point increases as well. Because it's heavier, it just takes more energy to get it into gaseous form. This is a secondary one. Notice if we compare these two, the mass, molar mass is the same. What's different is This is a secondary. This is a primary. So the primary is going to have more IMFs than the secondary. Hence, its boiling point is higher. We get down to tertiary. The problem with tertiary is we have something called steric hindrance. In other words, these groups here kind of keeps the nitrogen protected. Where with the primary, it's wide open. All this area. Secondary, we have this area. Tertiary, we have just this one little area where the hydrogen bonding can work. So strength-wise, primary is strongest, tertiary is weakest. It's the reason why it's weakest is because of steric hindrance. Okay, one of the reasons why dead things smell, one of the reasons is because we have some odoriferous amines. This is a 4-carbon diamino group. Same here, only this one's 5. Okay, so to name this would be the common name. Oh, excuse me. This would be the IUPAC. So we've got a dual branch with no carbons coming off of the nitrogen. So it's going to be a 1,4-diamino butane. Okay, the backbone is an alkane, like the backbone here is an alkane. Now, whenever we have an amine like ammonia, an H3 or whatever, in water, what happens, like I was talking at the beginning of this lecture, that the water can combine with the nitrogen and form a cation and an anion. The definition of a base is, can it disassociate a hydroxyl ion? So this met the definition of a base. Hence pH is greater than 7. Okay. So if we took, for example, methylamine in water, we form methyl ammonium ion plus a hydroxyl ion. Actually, it's spelled differently here. Hydroxyl ion. Now, like for my bug spray, we had this is called ammonium Ammonium hydroxide. Now, if you remember from Unit 3, whenever we have a fat triglyceride in a basic environment, we saponify it. And this is why ammonia is used to clean up greasy stuff. It's because it forms a basic solution. Hence, you can saponify fats. Also, if you get ammonium hydroxide on your fingers, for example, and rub them together, it's very slick. And that's because the oil in your skin is being saponified by the ammonium hydroxide. Hence, it's slippery, just like soap. Basically, it's turning your oils in your skin to soap. So whenever we have an amine in an acidic environment, what happens is the H plus forms a coordinate covalent bond with that bonding pair to form an ammonium ion. So this would be methyl ammonium chloride. So methyl ammonium chloride. Okay, so to name, whenever we have an acid and an amine together, they don't stay that way because the hydrogen from the acid forms that coordinate covalent bond with the nitrogen, forming an ammonium ion. So to name this, this would be the ethyl, ammonium, and this is the salt from the acid. Now this could be acetate or ethanate, either one. Acetate is the common name coming from acetic acid. And of course, this would be ethanoic acid. Okay, so the anion part of the ammonia salt is named at the end. So this is a tertiary, actually this is a quaternary nitrogen compound because we have 4 bonds and it has to be charged if it has 4 bonds going to the nitrogen. Okay, and this is where the lone pair is, where the hydrogen is doing a coordinate covalent bond with that hydrogen. So we have an ethyl group, 2 methyls. So it's ethyl dimethyl ammonium bromide. 3 ethyls, triethyl ammonium acetate. Now, because the ammonia salt IMF is greater than the original amine, The reason for that is this is ionic, and this is non-ionic. Hence, the ammonium salt version of the amine is more soluble in water, also has a higher boiling point. So this is more soluble. And that's water soluble than the plain amine. So from a medical perspective or a pesticide perspective or a food perspective, you can use this to your advantage. So this is what morphine looks like. And it's not dissolvable in water. If we convert this to a quaternary salt, like this, it becomes ionic and soluble in water. So when you, excuse me, get an injection of morphine, you're not getting morphine, you're really getting morphine sulfate. If it wasn't the sulfate, what would happen is it would sit in your muscle for a very long time. Now, when I was a very young guy, I had really bad asthma, and the only thing they could give me was vitamin B12, a non-ionized vitamin B12. They give it to me in my butt, and it would sit there for hours. And it was really bad. I could not walk. It was just horrible. And I had to get those treatments like every 3 or 4 days. It's all they had available for asthmatics in those days. This talk about the 50s. Really, really crude, but it is what it is. Okay, so this makes sense. What we're doing is we're putting an amine in an acidic environment. And this guy now is going to go over here and form this quaternary amine. Okay, so if we have an ammonia salt, so we have an ammonium chloride salt in a basic environment. So the pH is greater than 7. What happens is this guy grabs hold of that guy with this reaction here. So we have the hydroxyl group from the NaOH plus the proton stuck on the end of the lone pair here, forming water, and converts the ammonium salt to just the amine. So this is ionic, non-ionic. Okay, so if we have a carboxylic acid and the pH is less than 7, we get no reaction. We have an acid pH is greater than 7, we form an ionic now called a conjugate base, but basically, let's just say ion. It becomes ionic anyway. We have an amine, pH less than 7. We form ionic compound. Let's say compound. And the amine pH greater than 7, we have no reaction. Okay, you will have a test question on this. Now it helped to spell amine, right? Okay, now there's yet another class of ionic salts with amines. They're called quaternary ammonium salts. And they have 4 non-hydrogens attached to the nitrogen. Okay. And they can only exist in this form. And since they have no hydrogens on there that can come and go, that are attached to the nitrogen, that means it's pH independent. So notice we have three ethyls and a methyl, that's 4 attached to the nitrogen. That means that's a quaternary ammonium salt. Okay, to name that, you're going to name the 4 branches off the ammonia ammonium, and then the anion goes with the salt, chloride. Okay, these guys biochemically are all over the place. Last unit, we talked about choline, and we talked about phospholipids, and lecithin was one of the phospholipids that had choline attached via an ester to the phosphate group. I'm sure you all remember that. Okay. This is a neurotransmitter. It's a very important molecule in our body. Without this, certain biological functions will not happen. And there is an enzyme that when this goes across the synapse, it gets bound up to a receptor on the other side of the synapse. And what happens is that receptor then has to be removed, or excuse me, the neurotransmitter has to be removed from the receptor, otherwise the receptor can't function anymore. So there's an enzyme called cholinesterase. And what it does is it removes the choline from the receptor. Now, there is a pesticide called a cholinesterase inhibitor, meaning that it ties up that enzyme so the enzyme can't function to remove the choline from the receptor. So the nerve is basically shut down. With enough cholinesterase inhibitors around, the whole body is shut down. And it was used to be a very, very common pesticide. They're called well, they're called choline esterase inhibitors. Very bad. On my farm, we used to use a version of this to kill off navel orangeworm. The problem with it is it also kills off bees are mildly affected by this. So we also ended up killing some of our bees, but it was a trade-off between being totally infested by navel orangeworm versus killing off some bees. So we chose killing off some bees. Okay, and this is the part here that forms the ester with phosphoric acid on the bottom of the 3-carbon glycerol backbone. Um, these guys are used a lot. Used as antioxidant or antiseptic compounds, pesticides. There's used a lot. You've heard of Bactine probably. Some of these others I've not heard of before. So again, we have a nitrogen with 4 non-hydrogen groups on it. Hence, it forms an ion soluble in water, and usually it's the chloride version. Okay, now I said in some ways amines act like alcohols when it comes to reacting with acids. Excuse me, when that happens, we form something called an amide instead of an ester. Because we're talking about nitrogen versus oxygen, the IMF for is less than the IMF for esters. And again, it's because of the electronegativity of oxygen is more than the nitrogen. Now, the IMF for an amide versus an amine is less. Okay, so just like with an ester, we had an acid part and an alcohol part. So with an amide, we have an amine part and an acid part. Same way. Okay, so primary has 2 hydrogens. Secondary amines have 1 hydrogen. And a hydrogen is required to form the amide. If there are no hydrogens, an amide cannot form. That's why tertiary amines have 0 hydrogens. Hence, they can't form an amide. So there are 3 ways to make an amide. Only one way is so horrendously slow that it's not even considered a means to do it. They just say it's no reaction because it's horrendously slow. Okay, so that means just like with esters, there are 3 ways to make an amide. And the slowest way making an ester is using the original acid plus the alcohol. when we use ammonia instead of the alcohol, the yield is so low, it's considered no yield or no reaction at all. So that forces us to use the anhydride or the acid chloride to make the amide. Okay, so this is a 1, 2, 3, 4 carbon anhydride. That means the base of the acid is a 4-carbon acid. 1, 2, 3, 4 acid chloride. So this is the acid part. This would be the ammonia part, which should be this guy here. Kind of obliterates the so that's the secondary backbone. So to name an amide, you have to have the word amide in the name. So this is the acid part, amine part, buta amide. Now, if there were any groups over here, we have to name those as well. Now, like an ester, the alcohol, if we're looking at an ester, name, we name the alcohol part and then the acid part. Okay, with an amide, we name the amine group and the acid group, along with the word amide. Okay, so let's look at some examples now. So like with an ester, we have the acid part and the alcohol part. With an amide, we have acid part and the amine part. So primary backbone is 1, 2, 3, 4. Okay, and the amine part is that we have an ethyl group off the nitrogen. So we have to name that. So if we name this ester, it would be ethyl butanoate. That would be the ester part. With this, we're going to name it is N-ethyl butamide. So again, this is going to be alcohol part, acid part, amine, acid part. Same kind of naming. So we name the amine first, right here. The acid and then the amide. So this is, we put an amine in water. The water will pull off the H, forming a OH group pulled off from the water. If we put it in acid, we end up forming a salt. Okay, to form an amide, we would use the acid chloride version of the acid or the anhydride version of the acid. And this would be the preferred one for the same reason that it's a preferred one when we make esters, because the shelf life of the acid chloride is so unstable, it doesn't last very long. The yield is highest though, and that's because it's so unstable. Okay, now amines are used a lot in polymers. We are not studying polymers, it's out the scope of this class, so we're not worrying about polyamides. Now, we were looking at some synapse chemistry here. As you all know from your biology classes, the synapses, you've got a gap here, and what fires the synapse is a neurotransmitter. That's what these guys are. So if this is choline, and it comes over and lands here, the receptor fires, the neuron fires, boom. Now we have to have something called an uptake enzyme. If it's choline, it's cholinesterase, like I mentioned earlier. And the cholinesterase removes choline from the receptor site. And then it's able to fire again. However, if we inhibit this enzyme, like I was saying before, like in a pesticide, that enzyme cannot work, hence the receptor is shut down, hence the nerve doesn't fire. Boom. So if this happens to be in your lungs or your heart, well, guess what? Have a nice day. So these amines are really important. You've heard of dopamine, norepinephrine, serotonin, all these are amines. They're all over the place in our bodies, all over the place. Um, Neurotransmitters are synthesized from amino acids. To get dopamine, for example, starts with the amino acid tyrosine. So if your protein intake does not have enough amino acid tyrosine, you're going to have a problem synthesizing dopamine. And many of you have probably heard about dopamine being used to treat various things in our body. So also a pleasure center for a lot of abused drugs and sugar. Okay, you do not have to know these biologically important amines. I was just here just for your information. Okay, so the main point I want you to know are from here up. In other words, basically know the chemistry of the amines, how to make amides, what happens in different pH situations. Oh, and there's one other one here. If we have this in a base, we have no reaction. Okay, that's what I wanted to cover today. Are any questions? You may have a 3 by 5 card again. Now the test is going to be during Thanksgiving week. So next week will not be the test. We're going to go on to biochemistry next week. So here we are. Now we've finished, as of today, our OChem part of this course. And a lot of the biochemistry needs the background in OChem, but as far as OChem by itself, this is the last time we're going to be using, we're not going to be doing any synthesis. We're going to be looking at biochemical pathways that utilize synthesis, but we're not going to be deriving stuff like we've been doing before. In other words, how do you make this? What are the conditions? What are the reactants? If we have this and this present with this reactant, what do we get? That kind of stuff. That's strictly OChem problems. And that'll be what your test 4 will be like. Okay? There you have it. Are there any questions? My dogs are down here bugging me to go out.
Professor, I have a question.
Yes.
So Professor, I downloaded the new schedule and the test for is in the lab, correct?
Say again?
However, I downloaded the new lab schedule,
Yes.
and but I didn't know if we have the test for in person or online.
I still don't do do a chat.
Oh, okay. Okay, thank you.
Thank you, Professor. See you on Monday.
Okay, sounds good. Regarding test 4 online, I'm not sure. I don't like online tests because usually they're a group test. They're not an individual test. I during COVID, I was forced to do that and I didn't like it. I did it anyway, but I didn't like doing it. So the only time I do online tests is if I'm forced to do it. I prefer not to. I might, are you not going to be around that week?
So Professor, I can, Professor, can you hear me?
Yeah.
So I can come to class, but if it was online, it would be very good for me. But it's okay. It's okay. I will manage somehow.
Okay. All right. Um, if you want to send me a letter, we can talk about it some more too. Send me an email.
Regarding the test?
Yeah.
Oh, okay. Thank you, Professor. Professor, can we make an like an as like a Zoom office hour? Like, can we schedule something like that?
Sure. For when?
So I have some question regarding this upcoming test, and so if you don't have time, that's okay.
Well, we can do it. We have time because the test is until Thanksgiving week.
Okay.
Now, I do teach at Sierra College on Fridays and Saturdays. So I can't have a Zoom session on either one of those days. But if you wanted to have a Zoom session with you or your friends, that would be fine too, on other days.
Okay, so Professor, we are so as I saw at the schedule, so we are the test four is only like for the amines and amides, correct?
Correct.
And like I remember at the if I'm not wrong, so if we have like very low points at one test, so can you like I think you are going to drop one test, correct?
No,
Oh,
I'm not going to.
okay.
What I'm going to do
And
on test five, if test five is better than your lowest test score, I'll swap it out. In other words,
oh,
say you got a 60 on your low, like on test one, you got a 60.
mm-hmm,
And then all your other tests were okay. And on your final, you got an 85. I would
mm-hmm.
I would move the 85 over to your 60. So if,
Okay,
so if your test five score is higher than any other test, I'll move that score over.
okay.
Does that make sense?
Yeah, yeah.
Okay. The reason why I don't drop a test, lowest test scores, um, is because I've had students who get A's on the first four tests, and then they don't study at all for test five. They get a zero on it. They don't even take it, and they go, "That's my lowest test scores." So they end up with an A in the class without doing test five. That's why I don't do drop the lowest test anymore.
Okay.
That makes sense?
Yeah, yeah. Thank you, Professor. So, the only like I was wondering, so I think my test three was not that good, so that's why I asked that.
Understand?
Okay, Professor, thank you so much.
Sure. Okay, let me know on that, anything more in that letter, okay?
Oh, okay, Professor. Yeah. So I didn't hear anything from them. So, but like I did a mistake. So I also sent my other professor, which I told you about, that I have a Zoom class with him. So I also I also asked him for a recommendation letters because they wanted two professor. So and when I yesterday I talked to him, he said that I'm going to decline that because we only have like I only have a Zoom class with you and I don't know you. I don't know who you are. So he said that I'm going to decline that. So
Huh,
I said okay. And he Said
I
I'm not.
certainly won't decline it. I just need, I never got anything from them.
So, Professor, I think that they wanted two professor, but they were like sending the email only to one. So I'm very stressed about that because if they send the that email like the email to only my other professor, and he is going to decline that, so I'm going to lose that. So like I'm
Right.
trying to
That's why,
contact them.
yeah, that's why you need to tell them that that's the situation.
Yeah. And what I did wrong that I like before I write him as a I first didn't ask him for recommendation. I just write his name because we have a very good class. Like I'm always participating in his class. I thought like maybe he is recommending me, and he said no, this is not about the class. This is about what I know about you. And he said, I don't know anything about you. So he declined that.
Hmm. Well, that's not true with me. So
Yeah.
I'm anyway, you've got to see if your counselor can help you on that. Um,
So I have like about 2 more days. So I'm trying to contact them and tell them to send email to you.
yes, please do. And
Oh,
I'll be glad to turn that around very fast.
thank you, Professor. Thank you so much. You're helping me. It doesn't matter if I gave that or not, but you're helping me. That's a lot to me.
Okay. Yeah, well, it's my pleasure to help you.
Yeah, thank you, Professor. Thank you so much. And Professor, like I didn't know that on Monday we not have a class. So, but because in the schedule we had a lab, so I prepared like food, like the thing that I thought you may like it. So, and then
Oh,
the class was not. We didn't have class, so. mm,
well,
And I
that's too bad. I'd be looking forward to that. Okay,
yeah.
well, you got the thing prepared for Monday, and it's going to be very short. All we're doing is we're doing two things. We're going to analyze the aspirin you made in an infrared instrument, and that takes like 5 minutes. And then you're going to use the melting point device to get a melting point on it, which takes another 5 minutes. So lab is going to be very short today, and that's why I moved Monday's part over to next Monday because it's really short.
Oh yeah, yeah. I saw your email. Okay, so Professor, thank you anyway. You helped me a lot. So that means a lot to me. I really appreciate it.
Okay, I'm glad. All right, take care now.
Bye, Professor.
Okay, bye-bye.
Bye.